So in this question, we will see the five examples and we will check their corresponding increasing order of basicity of these molecules, starting with the example number one. So whenever you are dealing with these kinds of question in competitive exams, you have to understand the fact that you have to start with the hybridization of the different carbon atoms. So here we have to club these carbon atoms according to their hybridization first. So in the first uh, one, it is an sp3 based carbanion. The second also is sp3. 3 is an sp hybridized carbanion. 4 is again an sp3 one, and the last one is sp. So as you know, if we talk about hybridization, the electronegativity order of different atoms follows this trend: sp3 less than sp2 less than sp. sp3 has 25% s character, sp2 has 33.3% s character, and sp carbons have 50% s character. So depending upon this information, you might be understanding the fact that whenever we are talking about a negative charge, that is whenever we are talking about an anion or carbanion, so that will be stabilized on sp level of electronegative carbon atoms because it is already electronegative, so negative charge can reside peacefully there. But whenever the carbon is less electronegative, the negative charge cannot be stabilized that much. So here you can understand the fact that from the given examples, this 3, which is an sp1, and 5, which is also an sp1, are much more stabilized carbanions. That means they are not that much reactive in order of basicity. So 1, 2, and 4, they are actually much more basic than 3 and 5. Now, after clubbing these examples into separate categories, we now can say what is the order between these three and what is the order between these two. Now, let's come in between 1, 2, and 4. If you see 1, we have the plus I effect or the electron donating inductive effect from the three methyl groups, which will actually increase the electron density on the central carbon atom. So that's why 1 will have the highest basicity. If we go to the next example, 2, 2 is nothing but an allyl carbanion, H2C double bond CH CH2. Here, instead of the methyl group, we have two hydrogens to this carbon and one this vinyl group. So there, on by the virtue of this resonance, this negative charge can be stabilized, and this generates two equivalent resonance structures. So that's why this carbanion, which is 2, is a bit stabilized. But if we come to 4, this one, the CH3CH2 minus, it has only one methyl plus I effect. That's why its basicity is not as that much of I. So 1 will be greater than 4, that will be greater than 2. So this is the order between these three. Now let's come in between 3 and 5. So in 3, we have an sp level of carbanion. In 2 also, in 5 also, we have an sp level of carbanion. Now both are actually carbons are sp. Now here this is an sp carbon and this is an sp nitrogen also. As you know, the electronegativity of nitrogen is much greater than that of carbon. So that's why this nitrogen pulls a better minus I effect in comparison to this carbon. and that's why Cn minus is much more stable than HC triple bond C minus, which is acetylide anion. So that's why acetylide will be much more basic in nature. So between 3 and 5, we have the order that 3 is more basic than 5. So if we club these two comparisons together, we'll have the final order which is in increasing order. So 5 less than 3, less than 2, less than 4, less than 1. So this is the final increasing order of basicity between these carboanions. So that's how, by the judicious explanation and the reasoning, you can solve these kinds of question in JEE and NEET. We will see you in the next class. Thank you.